Hi everyone, I'm Niharika Gupta from Microsoft, and I'm excited to welcome you to this session on Kubernetes API gateways in cloud native service mesh strategies. Over the next 15 minutes, we will explore how modern enterprises are evolving their API management practices and leveraging service mesh architectures to build scalable, secure, and observable systems. Whether you are building large scale distributed systems, managing microservices across multi cloud environments, or modernizing legacy applications, this session will equip you with actionable insights and proven patterns. So let's dive in. Here's a quick look at our roadmap for today. First, we will discuss the challenges of scaling microservices in Kubernetes environments. Next, we will explore how service mesh technologies address these pain points through traffic management, security, and observability. Then, we will walk through practical implementation strategies. And finally, I'll summarize key takeaways and next steps. Let's start by looking at the challenges. As microservices proliferate across organizations, managing them effectively becomes a real bottleneck. We call this a service sprawl, where the number of services outspaces the ability of traditional API gateways to manage them. Coupled with this slow deployment velocity, integration bottlenecks that delay releases and reduce agility. As Kubernetes clusters scale, the complexity multiplies. Without modern orchestration and traffic control, teams struggle to deliver at cloud speed. Traditional API gateways were never designed for distributed container based architectures. They often become single points of failure, creating operational strain and risking downtime. Manual service discovery and static configurations are another pain point. They simply don't scale in dynamic multi cloud environments. Persistent configuration drift across dev, staging, and production introduces inconsistency and instability. And finally, the overall operational burden is high, slowing down innovation. API gateways plus service mesh. This is where Kubernetes native API gateways combined with service meshes come into play. Together, they create a layered architecture that provides end to end traffic control, unified policy enforcement, and holistic observability. By integrating these tools, organizations accelerate development, enhance security with granular policies, and improve reliability through advanced traffic steering. The result? More agile, scalable, and resilient applications, and a true competitive edge. Real world scale. In production environments, these architectures shine. Teams can seamlessly manage containerized microservices across hybrid and multi cloud setups on Azure, AWS, or Google Cloud, while ensuring high availability through automated failover mechanisms. This reliability is key when scaling enterprise workloads to thousands of services without compromising performance. Let's take a deeper look at service mesh components. At the heart of Istio, for example, is the control plane, managing policies and service discovery centrally. Envoy sidecars handle intelligent traffic routing and load balancing at the pod level. Security is reinforced through mutual TLS or MTLS, ensuring zero trust communication between services. For teams looking for lighter alternatives, Linkerd offers simplicity and efficiency, delivering MTLS, traffic routing, and observability with minimal resource overhead. Modern service meshes enable powerful traffic management strategies. Let's explore three key ones. First, automated canary deployments. These progressively shift traffic to new versions, monitoring health in real time and rolling back automatically if issues arise. Second, circuit breakers. These isolate faults and prevent cascading failures across services, critical for maintaining resilience. And third, intelligent load balancing, dynamically routing traffic based on real time metrics to ensure optimal performance and resource utilization. Cloud native authentication and authorization. Security is non negotiable. Kubernetes role based access control or RBAC enables granular permissions defining who can do what inside the cluster. By automating service accounts and enforcing least privilege, RBAC enhances multi tenant security. Complementing this, OAuth 2.0 and JWTs allow for secure, stateless authentication across APIs, integrating with external identity providers and simplifying API key management. Comprehensive observability stack. You can't improve what you can't measure. A complete observability stack combining Prometheus for metrics, Grafana for dashboards, and Jaeger or Zipkin for tracing, ensuring full visibility across microservices. This enables proactive monitoring, root cause analysis, and data driven scaling decisions. DevOps is standardization with Helm. Helm charts are the package managers of Kubernetes, standardizing deployments and enforcing configuration as code. They ensure consistency across development, staging, and production. Key benefits include reusability, version control, and dependency management, essential for scaling complex microservice ecosystems. Intelligent rate limiting and scaling. Adaptive rate limiting dynamically throttles traffic based on resource availability and downstream health, preventing over paired with auto scaling integrations like HPA and VPA. You get intelligent scaling and cost optimization across cloud providers like AWS, Azure, and GCP. API monetization strategies. APIs are not just technical assets, they are business products. Usage based pricing and analytics driven insights help monetize APIs effectively. Namespace isolation supports multi tenant models, while developers self service portals improve discovery and adoption. Developer self service capabilities. Empowering developers is critical. These operators and custom resource definitions enable self service management, automating complex lifecycle operations, and embedding GitOps principles. This reduces operational overhead and accelerates delivery cycles. Implementation framework. A successful rollout starts with a clear framework, assessment and planning, evaluate your current architecture. Second, deploy the service mesh, Istio or Linkerd with the right security. Third, integrate your API gateway, align traffic management and observability. Finally, optimize for production, fine tune for performance and scale. Transform Kubernetes complexity into competitive advantage. By adopting these strategies, organizations can transform Kubernetes complexity into competitive advantage. Proven blueprints enable managing thousands of services. Monetization unlocks revenue, and automation drives operational excellence. To wrap up, unify API management with Kubernetes native gateways, empower service meshes for resilience and observability, prioritize automation and GitOps for consistency, embed security and compliance from day one. Thank you. Thank you for joining me at Conf42 Kubernetes. I hope this session provided valuable insights into building scalable, secure, and observable cloud native architectures. Connect with me on LinkedIn if you'd like to continue the conversation. Until next time, happy building.